Now, okay, yeah, and this one is unnecessary. Yeah, now you should hear me. I apologize. I apologize. I didn't look into the chat window. I'm sorry about it. I'll then try to edit the stream, the YouTube stream, when it gets published, so that you can start watching from where it really matters. So I'll go through eager loading again, just very quickly to tell you the basics. So we got this situation in which you want to retrieve records from the database. In this case, we're retrieving clients. We've got 10 clients which we are retrieving from the database. So then we are sort of looping through the result set, and in each loop, in each iteration, we are retrieving the client address. Client.address is of course an association by which it is possible to obtain the address of a client. Therefore, we have conducted one initial query to retrieve the 10 clients, and then we are conducting 10 other queries to retrieve each client's address. So we have a total of 11 queries we're running. The first one, which retrieves the 10 clients, and the other 10, which will retrieve the address of each client. So this is a very frequent kind of situation, a very frequent scenario. It's very common to see this in situations in which you retrieve a large collection and then you need to get some associated model. And the way in which this is done in the example is very inefficient, because generalizing what you got is n+1 queries. You want to minimize the amount of queries or the amount of database queries that Rails does against the database for performance reasons. Each query will take time. It's much better to do one query rather than doing 11. There's overhead in between each of the queries you want to perform. So it's best to minimize the overall queries you do, and the way to do that is to use the includes method, as you see in the example below. We got the same example about the clients. Now what we're doing is to include the address. You see, the address is the name of the association. I haven't shown you the model, but the model should say the client has one address, right? So the client will, in this case, the query will include 10 clients and their addresses. So instead of querying the address each time in the loop, the addresses here in this loop below will have been already loaded from the database, and you don't have to perform separate queries to retrieve each address. This will translate to the SQL statement at the right. You see there's a select asterisk from clients, limit 10, and which is followed by another select statement in which the addresses will match the client IDs. So there we've got just 2 queries instead of 11, and that's a very good optimization. So I hope you remember in the future, when you need to retrieve associated models, please use the includes method rather than simply querying on a loop, right? Because that is very inefficient and won't scale well if you at some point you want your application to be reliable, to be well performing in a production environment. There are other possibilities for eager loading. This is very similar to the joins you've already seen. For example, if you'd like to include 2 associations, you'd like to include category and you'd like to include comments, you simply put the association names as symbols as parameters for the includes method. Finally, you see there's a more complex kind of inclusion, in which you got sort of nested inclusions. You want the articles to include the comments that have been written by some guests, and you also want to include the article tags. Well, this is quite the same as the last example in the joins. In the joins, you'll see in this class and in the video published before. The joins are, of course, in slides 30. Yeah, 37. You see, there's the same example here, and you see eager loading. It works quite the same way, right? Because it will load from the database by following the different associations that are available in the model, right? I hope you now follow me. I'm glad to see that you're listening. So now the second more advanced topic I need to show you about Active Record is how to handle transactions with locking. Or how to handle database operations with locking. Transactions is one way of doing that. So imagine the situation in which you got a model that is modified by different users concurrently, right? The model will have perhaps different attributes, and some of these attributes can be edited by two users or more users concurrently. For instance, if you got a text, if you are sort of editing a wiki among many users, it may happen that one user will write on one paragraph, another user may even write on the same paragraph, right? And if both users press the save button after doing the modification, well, we have to provide some synchronization mechanism so that the data remains consistent. So in this case, when we want to control concurrency in model access, we've got two patterns available. We've got optimistic locking and we've got pessimistic locking. What happens on many kinds of web applications, for instance, e-commerce applications, you'll have just one user with a shopping cart going all over the store, putting stuff in the shopping cart and then checking out. You won't have two people using the same shopping cart, right? So the possibility into running into synchronization issues is less likely than in other kinds of web applications in which you got collaboration, such as a wiki, right? So optimistic locking can work pretty well on e-commerce kind of applications. For instance, a ticket purchase, a ticket shop like the one you're working on in the lab assignments. Well, that can you can live well with optimistic locking. The most likely thing is that optimistic locking should work well. But then if you got a more sophisticated kind of interaction, perhaps you got many users interacting against a shared object. You got shared objects, you got shared artifacts, you got shared models, then what you need is some more robust kind of mechanism, and there's when pessimistic locking kicks in. So optimistic locking, I'll just talk about it briefly. Well, we've got that the model has a special attribute, which is the lock version attribute. The lock version attribute is simply an integer number. So whenever the record is updated, active record will increment the lock version column, right? If an update is made with a lower value in lock version than the current lock version in the database, the update request will fail because there's a more recent update. You see, it may happen that there's overlapping of updates. So another user came more recently to make the modification and the lock version incremented. So the first user will attempt to save. When the first user attempts to save, the lock version will be incremented, will have been incremented by the second user, and an exception will be raised. The stale object error will be raised if the lock versions are inconsistent. So this is the example I just described. We've got client 1, we've got client 2. Suppose these are two separate, well, these are actual queries that can go on, right? So customer 1 will have its first name modified, then it will be saved. Then customer 2 should fail. Upon saving customer 2, there should be a stale object error. And well, the thing is that let's see. This is I'm not quite certain this is an actual true example because these are two different clients. You see. You got, I'm sorry, these are the same client. I forgot to realize, I forgot to emphasize. Do you see the parameter? Client find 1. That means that both client 1, C2 and C1 refer to the exact same record. That is what I intended to say. You know, I got a little lost. But anyways, I hope you now follow. So C1 and C2 are objects that have been obtained through two different queries. Client find 1 is one query, client find 1 below is another query. So those two objects were retrieved by different queries, being the same record in the database. So now we are modifying the first name and saving it. Then when we attempt with C2 to change the name, oops, the record had been modified previously, so an exception is raised. Yeah, that's what the example is about. So whenever you got two objects referring to the same model, to the same record in the database, situations like this may happen. But again, as I was telling you, this is unlikely to happen in a scenario in which you have a single user interacting with a set of records, against which no other user will interact in a given time, in a given time window. So there are ways to handle the exceptions you get. You got this exception, this tail object error exception, and you are the responsible party. You as the developer, you must see how to handle this error. You can either show the user an error occurred, please try again. The please try again part is real in this scenario. As it is optimistic locking, it may happen that no other user is modifying the model, so you can have your user try again. It's very unlikely that this kind of situation happens again in an e-commerce kind of scenario. But if you got another kind of more complex interaction, well, then perhaps you'll have to reconsider optimistic locking. Perhaps optimistic locking isn't the best option. Perhaps you'll have to try pessimistic locking. So pessimistic locking depends on the database management system capabilities. Here we got an entire market of different database management systems. Many of them, many of the ones used in production systems will support transactions. A transaction basically allows you to run a SQL query, ensuring that no other transaction will modify the same record, right? So transactions are basically known as being atomic. That means that they run in terms of all or nothing. If the transaction fails, it is rolled back automatically, and then it can be reattempted. So the way to implement transaction-based locking in Rails is to use a transaction scope. You use a transaction scope. So you see you got a model called item, and there's a method called transaction. To the transaction method, you pass a code block, as in the example here. The code block will contain item log first, so it will modify the name, and then it will save. So the resulting SQL below will show you that there is a transaction. Begin commit. You see, that's the begin. A transaction always begins with begin, and when the transaction will be committed to the database, well, of course, the keyword commit is used. So not all databases support transactions. For instance, SQLite you use in the development environment in Rails won't support this. SQLite isn't intended for a production environment. SQLite is only intended for a local development environment in which you are perhaps the sole user in the application, sort of running tests or developing, but you never intend to run an application serving several concurrent users with SQLite, okay? Okay, so before jumping to the next topic, which now doesn't have much to do with the model layer, this is an introduction to the controller layer. I'll go back to the forum, to the chat, and see if there are any questions. Yeah, I went a little fast with the eager loading because I had to explain it twice. Well, of course, you can go back in this video. You can see the details on the slides. The examples, of course, are the most important part. Check on the examples. Check on what eager loading does by, well, going to the start. You see you got the n+1 queries problem because here you got one query and here you got other 10 queries. So it's 11 queries in all, and you want to avoid that. So you got eager loading. And eager loading, you can do it simply by including one association or including many associations. You can even have nested associations for eager loading, very similar to the joins. Then about database locking, what we want to achieve with database locking is record consistency in the database when you have several concurrent users using your application. So there are two versions of this, the optimistic locking and the pessimistic. The optimistic locking will be suitable in scenarios in which you have perhaps only one user at a time interacting with the models. You see, I was giving you, again, the example of an e-commerce application with a shopping cart. It's unlikely that you'll have two concurrent users using the same shopping cart. So optimistic locking should work quite well, right? Whenever you got a problem with optimistic locking, then this exception raises. And when this exception raises, you can just handle it and show an error to the user, tell the user to try again. And that's quite reasonable because this won't happen very frequently. And allowing the user to try again will likely fix the problems. So when you got optimistic locking, basically you got a lock version column, a lock version attribute, numeric attribute in the database, right? So these two queries that you see here, C1, C2, these are two separate queries, querying for the same record. So the first object modifies and saves the record. The lock version will increment, and when C2 attempts to update another attribute and save, will fail because the lock version will have been incremented by this operation. So optimistic locking will always check on the lock version when the save method is invoked. So when the lock version changes, this lock version had a number here, had a number after the save, a new number after the save, an incremented number, then C2 will check on that number to see if it's the same as here when it saves. The number is different, okay, have to raise an exception. That's simply optimistic. Then pessimistic will depend on database management system capability. It will depend on transactional support. And here you see how to do it. You got the transaction method that is available to any model in your model layer. You got client.transaction or order.transaction, and you can do this if it is supported by the DBMS. But I just told you, no, not all DBMSs will support transactions. Only perhaps the top end, such as Postgres, Microsoft, SQL Server, Oracle, all those will support transactions. But if you go to sort of a cheap version of MySQL, with there are two flavors of MySQL. You got the MySam and you got the InnoDB. The InnoDB will support transactions, the MySam won't. So you have to be careful on about what database management system you're using. If you're using SQLite, of course, you won't have transactional support. Right, so now I'll jump to this new topic, which is REST. This doesn't mean, of course, that we'll rest. Well, pardon me the joke. It's sort of unavoidable to make jokes about REST. So REST is an architectural style, as MVC is an architectural style. You see, the web application framework we are covering in this course is based on the model view controller architectural pattern. There are, of course, many other kinds of architectural patterns in software architecture, in software development. One of them is REST. REST has become very, very influential, very important in web technologies, in web architectures. REST is an abstract architectural style. It can have many implementations, the same as MVC. You got MVC on .NET, you got MVC on the Rails ecosystem, on the Ruby ecosystem, you got MVC almost anywhere. And you see that REST, similar kind of thing is happening. So what characterizes the REST architectural style? Well, first we got a client-server architecture, which is of course the architecture we always see in the web. We got clients and servers. We got statelessness. That means that each request from a client to the server must contain all the information that is needed to process the request. And this is intended to support replication. You may have many servers serving an application, and statelessness will allow the client to connect to any of the servers and continue the workflow, right? If we had a state saved in the server, then the interaction would be limited to that particular server. Statelessness will enable scalability. It's very important of course, in web architecture to have scalability. Then the third feature of REST is caching. Caching means that we want to avoid the client having to retrieve the same resource all and over and again each time. The URL is entered by the client on the web browser, for instance. So a web browser will have cache, for example. The browser will cache content that is downloaded. Images won't be downloaded every time the user goes to some website, right? There's cache control. Some resources can be cached, some others cannot be cached because they are updated too frequently. So caching is a third requirement or third key characteristic of a REST architecture. Then the fourth characteristic is a uniform interface. So with REST systems, you expect to have a consistent interface to manipulate resources. In the web, this is accomplished by means of HTTP. HTTP will define a uniform interface, as you see at the right side, the image on the right. You see that HTTP supports different actions by verbs. You got the get, you got the head, you got the put, the post, the patch, the trace, the options, the delete. Those are different verbs that are possible and that conform a uniform interface. That means that a web browser can talk to any web application through these methods. Also, if you got a mobile application, the mobile application can talk to a backend, a web backend, by any of these verbs, these HTTP verbs. So in the web, you may have different representations for resources. In a REST architecture in general, you can have different representations for resources. HTML is very frequent as a representation, right? If you wanna, for instance, go to some news article on Emol or La Tercera or whatever, that very article is a resource, you see, and you get the article, and that article, if you see it in the web browser, well, it's HTML. But if you got a mobile application, perhaps the format is a little different. It is not HTML, rather it's a stream of objects, a set of objects that get then rendered somehow, right? So the representations can vary, but the interface to access, to manipulate the resources is uniform. It's always the same. It's kind of a consistent kind of interface. The fifth characteristic is a hierarchical layered architecture. This is quite broad. It may comprise several layers of the network, of the application stack, you know. Layered architecture may mean that you have firewalls on the network, or that you have proxies, or that you have, I don't know, authentication systems. But in our particular case, we're working with the MVC architectural pattern, which will enable a layered architecture. We have different layers. We just saw about the model layer. We're now starting to see about the controller layer, and we got another layer, the model layer, the view layer. We'll see later. The sixth characteristic is code on demand. On REST applications, the client capabilities can be extended by downloading code, by downloading scripts, for instance, and we'll cover that when we see the view layer. So the REST architectural style is about 20 years old. It got developed by Roy Fielding in his doctoral dissertation in UC Irvine, and it's been very, very influential nowadays. Right, so Rails applications will conform to the REST architectural style. We got the client-server architecture that is hierarchically layered, because of what I just explained. We're adopting an MVC architectural style, which layers the application sort of hierarchically. Even though we can also have other layers into consideration in the communications network. As I mentioned, we can have firewalls, we can have caching proxies, we can have many other stuff layered on the infrastructure as well. So our Rails applications we call them resource-centric, because the metaphor is that the client, the user, will always want to access and manipulate a resource. The client basically wants resources all the time. Resources. Give me resources, update my resource, create a new resource for me, delete our resource, okay? So these are all resource-centric operations. And the definition of resource is extremely abstract, extremely general nowadays. It will encompass everything, entity, or action that can be identified, named, addressed, handled, or performed in any way whatsoever on the web. That's a very broad definition, indeed. So now that we've seen just a glimpse about REST, so what we understand is that this is an architectural style that comprises all of these different layers, including statelessness, including caching, including client-server architecture, hierarchical architecture, and code on demand, and so on. It's time to see now what happens in Rails, how it complies with the controller layer, okay? I'll go back to the chat. Okay, no new questions. So this diagram at the right side of the slide, you've seen it already, you know it. We got the different parts of the process that is required for a server to handle a client request. So we got first the web browser asking the application for users. You see, it's got /users. That's sort of the path that the client wants. That means that the server ultimately will have to respond with a list of users, an index of users, if you will. That's the meaning of users. Users is, if I tell the server I want to get users, the server will give back to me a representation of all those users I'm interested in. Possibly it's about all the users that are in the system, a list of all the users. So then there's a component called the Rails router, which is part of the controller layer, that will take that request and forward it to a controller. There must be a controller that is capable of handling the request. Otherwise, it is most likely that the client will get an error. The client will get a 404, not found. If or possibly a 400 error, which is bad request. Or even maybe a forbidden, a 403. The client can also get a 403 if the request isn't allowed, is forbidden. The controller, which implements the business logic, the business rules. What should happen if the browser wants to see a list of the clients? Well, what I should do as a controller, I'm thinking as a controller, I have to go to the model layer and ask for all the user records that are on the database, all the user models. So steps 3 and 4, you already know them. We've already worked our ways with active record. We have created models, we have created associations, validations, callbacks, etc. So the controller will ask the model layer for all those users, user.all in this case. If you watch the video on queries, you see that user.all isn't optimal. User.all will load all of the users into memory. It's best to take the users in batches, to read the users in batches, and all that. So then what will happen is that the controller will instance a view template for the response. It will take the view template and will populate that template with the users. Step 6. Step 7, the view will get rendered as HTML. And step 8, the controller will send back the view containing the users back to the client. So that's the entire round trip. You see, that comprises 8 steps. We should now understand, hopefully, how steps 3 and 4 work. Now we'll see what happens with steps 1 and 2. We'll start with just steps 1 and 2. You already know 3 and 4. So 1, 2, 3, 4, you'll manage about half of this round trip we've seen. And the fundamental Rails component that takes action in steps 1 and 2 is the action controller. You just saw active record. Well, now we've got action controller, which is another component of the Rails architecture. It's actually the C of the Rails architecture. So controllers will process the client requests, will manipulate models, will perhaps update, create, will conduct CRUD operations on models that are involved. And well, the controllers the controllers are basically classes. Okay, a controller is a class that will contain many methods. Each of these methods will respond to some request. The request is identified by the HTTP method that is used and the path. We've got an HTTP method, then we've got the path. The path will tell the path, and the method will tell what controller and action should be executed. We'll see that in a minute. So a controller action that responds to post requests, it is expected to be able to process several incoming parameters. For instance, when you submit a form, that form will contain several different variables. And those variables are interpreted as parameters. Whenever you got a controller that handles that post request. Post request will result in models being created most of the time. Then you may have a controller action, a controller request, a controller method that will process GET requests. In this case, it's about resource delivery. You want to deliver resources back to the client using some form of representation. You can use an HTML page, or you can also deliver plain text, or objects, even objects, serialized objects. You've seen serialization in your object-oriented programming course on .NET. On the web, we have sort of a standard de facto for serialization, which is called the JavaScript object notation, or object notation. There's a very renowned author in the JavaScript ecosystem called Douglas Crockford, who wrote a book about JavaScript, very well known, JavaScript, The Good Parts, or something like that, I think is the title. And this author, Douglas Crockford, invented JSON about, I don't know, maybe more than 15 years ago, it must be. So I was telling you controllers are basically classes. These classes will inherit from the action controller base class. The corresponding files are located at Rails root app controllers. There you see the controllers of your application. So in any newly created application, you will see that there's a controller called application controller. Initially, this controller is empty, but it inherits from action controller base. This controller is intended to be the base controller for all the controllers or most of the controllers in your application. You see, here in the application controller class, you can implement any logic that is common to all different controllers in your application. That might be the case if you want to implement an authentication system. If you want to offer authentication, that is the capability of the user being able to log in with username and password, and you want to keep the session state going on, right? You can handle all of that logic in the application controller class. Makes sense. So there are naming conventions, as it was the case with Active Record. The conventions are to pluralize the name, right, of the controller. Usually you create the controllers to handle some kind of resource. The resources will often match the names of the models. So you see, if you got users in your model layer, the users can be delivered, the user objects or information about each individual user, or even a set of users. All of that information can be delivered back to the client. Maybe the client is interested in that information. So then it makes sense to consider the users a resource. You usually consider models resources. There's sort of a one-to-one relationship that you can basically say that any model in your database is potentially a resource that can be delivered to a client, right? So being that the case, the controller names will match the model names. You got client's controller because you got a model that's called client, and client is a relevant resource to some user of your application. So you pluralize the controller names in such a way that you got client's controller, site admin's controller. There's an exception, of course, for application controller. Application controller is sort of a singleton, right? You only got sort of one web application you're working at a time. You have one big application. You're not controlling many different applications, so it doesn't make sense to pluralize the name of this application controller. You just keep you keep it that way. Application controller is sort of the standard way. Right, so I was telling you that controllers will contain methods, as these of course are classes. The public methods of the controllers are called actions. These can be understood as the controller capabilities as to how the controller can handle a resource, the resource life cycle. I'll show you about that in a minute. So imagine, for instance, a form that has been filled out by a user and then is submitted to the application, right? A controller method will process that request and process the data that the user entered in the form. That controller method will be called also an action. So action methods will eventually perform model layer operations because these implement the business logic. The steps 3 and 4 of the diagram I showed you at the beginning. Methods in controllers could also be private or protected. In that case, these are not actions, but helper kind of auxiliary methods in order to avoid code repetition. There are also other methods which are called basically filters. Filters are very similar to what are the callbacks. The callbacks in the model layer, you see that the callbacks are triggered before the model is saved, after the model is saved, before it is deleted, after it is deleted, and so on. Well, with the filters, you can execute code before the action is executed and after the action is executed, or before and after also. Again, if you got something like an authentication system, you'd like to check first if the user is logged in before executing the action. So therefore, you'll have a filter for that. So what does a typical controller look like? I just told you about the naming convention and the fact that the controllers are often related to the models because, well, controllers will handle resources and models are basically resources. So controllers will provide the necessary logic to handle the life cycle of the resource, and you can see that represented, that is becomes evident with the methods that are sort of the standard in a RESTful controller. A controller that implements a RESTful architectural pattern will have these operations. You see, you got the index action of a controller that will deliver a list of all available resources matching the resource type. If you got users controller and you got index, that should give you a list of users, right? If you want to see a particular user, you got the show action, which will get invoked whenever the client sends a GET request with the ID of the resource, commonly with the ID of the resource. The client will like to see user 37. So it says, okay, give me users 37, get user 37 to the server, and the server will send back a representation of that user on HTML or otherwise. There's the new action. The new action will provide an interface, web form, through which the user on a web browser will be able to create a new model. You see below the create action. The create action is different to the new because the new will simply deliver the interface. The create will actually store the new model in the database. I hope that's clear. I will emphasize in Spanish because I think this is very important to note. Tenemos todas estas acciones, métodos de un controlador que son como los métodos RESTful, digamos los métodos que implementan el patrón arquitectónico, el estilo arquitectónico REST, ¿ya? Tenemos el index que devuelve una lista de todos los recursos. Por ejemplo, si un controlador de usuarios, entonces index va a devolver una colección de usuarios con su representación en HTML o en otro formato, ¿ya? Las representaciones para los recursos pueden ser variables, no solo HTML. HTML es lo más común para el usuario que usa un navegador web, pero si estamos en una aplicación móvil, hay otros tipos de representación como la serialización de objetos usando JSON. ¿Ya? Entonces, el index te muestra la lista de usuarios, el show te muestra un usuario, tú le puedes pasar el ID, a la petición get, dices quiero el usuario 37, entonces va a hacer get con algún path que va a incluir el ID 37 de usuario, probablemente va a ser get /users/37, ¿ya? Y eso el servidor entiende que tiene que ir a buscar el usuario 37 y mandar de vuelta una representación, que puede ser HTML u otro formato, ¿ya? Y así tenemos después la acción new. La acción new lo que hace es entregar una interfaz para el usuario construida con HTML, que es básicamente un web form a través del cual el usuario puede ingresar los datos para luego crear un nuevo recurso. Y ahí está la diferencia entre new y create. New lo que hace es entregar una interfaz y create lo que hace es crear un nuevo recurso utilizando los datos que fueron ingresados a través de la interfaz proporcionada por new. ¿Ok? Después está destroy, que lo que hace es borrar un recurso. Hay un cierto truco, digamos, en este sentido, porque no queremos que un usuario en su navegador web pueda mandar un delete request y borrar cualquier recurso en el servidor. Eso no tiene sentido, eso tiene que ser protegido siempre. Y si es que el usuario tiene los privilegios, tiene los permisos, permitirlo, ¿cierto? Lo otro es que por seguridad los navegadores web no implementan delete, que es un método HTTP del estándar HTTP. Lo que hace Rails es utilizar post y una variable de petición que va en la cabecera del request que pide que determinado recurso sea destruido. Se ocupa post, se instrumentaliza post pasando un atributo que en realidad dice que el request es para borrar un recurso, para eliminar un recurso. Después está edit, que es análogo al new. Edit lo que hace es proporcionar una interfaz para poder editar un recurso que ya existe. Es decir, nos va a entregar un formulario, un web form, que ya va a tener los campos rellenos con la data del recurso que queremos modificar. Y finalmente está update, que responde al método HTTP patch. Update va a actualizar el recurso. ¿Ya? Okay, so I'll switch back to English. So this is what a controller typically looks like. We got a post controller class that inherits from application controller. We see there are filters already implemented here before action find post. We will cover that later. It's not the subject of this class right now. Anyways, we've got several different methods here that are, of course, the controller actions. We've got the index action that will go to the database and fetch all posts and store and keep all those posts in an attribute variable of the class. You see the at symbol with posts, that's an attribute variable. Es un atributo de la clase cuando la variable tiene un arroba al principio. Acuérdense, son Ruby, ¿ya? Es sintaxis de Ruby. Después cuando está el método show está vacío, ¿por qué razón? Porque application controller ya y la clase base de action controller, claro, la clase base ya implementa el funcionamiento del show, ¿ya? Y uno, por supuesto, puede hacer overriding de eso si es que escribe código en show. Pero show se asume que lo que hay que hacer es mandar una representación del objeto de vuelta al cliente y por default va en HTML, ¿ya? Eso es. Then we got the new action. The new action, I told you, what it does is to deliver a web form to the user. So in this case, what we do is to create an empty object, an object that hasn't been recorded yet to the database. You see post.new won't save the object to the database. It's just a blank object. And we keep that as an attribute because later on, when the controller goes to fetch the view will contain an empty post that the user will then fill in by using the form fields. Entonces, el atributo post que queda en el método new es luego utilizado a nivel de vistas, porque la vista va a necesitar un objeto para mostrarle al usuario, ¿ya? Entonces, la vista de new va a mostrar un web form a través del cual es posible llenar todos los campos que permiten crear luego un post. And you see there, the create method. The create method will retrieve the parameters of the request. You see there's a post params method call. You see the post params method call in the private section of the class. ¿No? And what post params does, we will see it in the next class, but basically is to control what parameters are allowed. Por razones de seguridad, no podemos permitir que un usuario le pase cualquier parámetro, cualquier información al controlador, y lo que hacemos es filtrar los parámetros que le llegan al request. Entonces solamente permitimos que pueda ingresarse un título, un contenido y una ID de categoría como parámetros de un post, ¿ya? Por eso el create llama a este método para filtrar los parámetros y luego crea este nuevo objeto y trata de guardarlo después, ¿ya? Si es que logra guardarlo, hace una redirección a mostrar el post creado, mostrando un mensaje, el post fue creado, ¿ya? En caso contrario, el create devuelve el usuario a la vista new para crear un nuevo post. Okay, the edit has no code for the same reason that show doesn't have a code. Edit will sort of have a default behavior that is implemented in the base class, and you can of course override it. You got the update, which is quite similar to the create, and finally you got the destroy. So if you got to destroy, you basically delete the record, you delete the object, and then you are redirecting the user to the root path of the application. So how do you create a controller? Well, you saw there are generators for almost anything in Rails. You got generators for migrations, you got generators for models. There are, of course, generators for controllers as well. So it is important to understand what the generator does. You basically pass the generator the name of the resource for which the controller will be created. So the name you pass on the command line, it can be a noun. Right? It's almost always a noun. You see, it's always an order or a customer or a user or whatever, you know. So Rails G controller user, right, will create a controller for the user resource. For users, actually. Users controller. You can then pass a list of actions, the usual actions such as new, create, delete, destroy, blah, 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 blah. And yeah, and it also allows a set of additional options, because when you create the controller, also other files will be created as well. I'll show you this in a couple minutes. There's a small detail, a small subtlety. I would call this a bug. On Rails 6, it may happen that when you run the generator for a controller, it gets stuck, it freezes. The workaround that I could find is to run this rake task below app update bin that will sort of conduct some updates. I'm sorry about this Java interrupting my class. Rake app update bin, you run that and will fix Rails for you, and you can run the controller generator again. So when you create a controller this way, you see you got Rails D controller, events controller. Well, this is well, one possibility. You can pass the exact name of the controller, or you can pass just the noun. I could have passed event, and the result should be the same. I recommend that you simply use the noun. I could even change this slide to reflect that. Anyway, so then we've got the list of actions, right? Index, show, create, new, edit, blah, blah. And what happens is that the controller gets created, and also views get created, and also unit tests get created, and a helper a file for helper methods gets created, and so on. Even a style sheet gets created. So many other stuff gets created by default. There are some controller, some generator options you can pass along, so that none of these views or unit tests get created. So when no options are passed, it will generate the class file for the controller, a view for each action, a test for the controller, a helper file, assets. So if you don't want the assets, you don't want the helper, you don't want the views, you pass along these options to the generator. No views, no assets, no helper. You can destroy a controller by calling Rails D controller, and you pass the controller name. That Rails D means Rails destroy. Instead of Rails generate, it's sort of a destructor instead of a generator. So the Rails destructor you can also call it for migrations, and you can also call it for models. If you haven't seen that before, I think I stressed a little about it when we saw models. There's another generator that will create what's known as a scaffold controller. When you run this generator, the controller generator, the standard one, this one, if you open events controller, it will be an empty class. You won't see any methods inside. All behavior will be available from the base class. But many times, I'd say most of the times, you'd like to customize, you'd like to override the default behavior. So in case you'd like some controller that contains the RESTful methods already implemented for you, you run scaffold controller instead of just controller. If I got a minute, then after I show you these concepts, these slides, I'll go to the terminal and quickly show you about these generators. Then the last topic we need to cover in this class is routing. Before I jump into routing, I'll just do a small pause. Okay, no new questions so far. Just like to see how many people are there watching. I'm a little curious about that. Okay, less than half of the class. I suggest that you watch the classes, even though I publish the videos. The videos remain published later on, and you also got some other material. I bet most of the students who are watching are computer science students. No, I hope many students from other majors are also watching. The subject of web applications is very complex, as many layers interact. Each layer has its own technology, its own definitions, its own concepts. So it's important that you keep on studying. Otherwise, it's easy to get lost. So what is routing? Routing has nothing to do with internet routers here. We're not talking about IP routing or whatsoever. The routing system is in Rails. Routing systems also exist in other web application frameworks. You know, if you go to the Java platform, even if you go to .NET in Microsoft World, or if you got to Python frameworks or whatever modern framework you look at, you'll see that there's a routing system. The routing system will examine an incoming URL. You basically will take the client request and infer from the client request which controller must be run, which specific action in the controller must be run in order to service the request. Entonces el sistema de routing lo que hace es mirar la URL y mirar el método HTTP de una petición entrante y decidir a qué controlador y qué acción, qué método de controlador tiene que derivarse la petición para poder ser procesada. ¿Ya? So a Rails application will define a set of routes telling how URLs are supported by the application are mapped to controller actions. Entonces, estas definiciones de las rutas, de cómo se mapean las peticiones a las acciones de controlador, están dadas en un archivo que está guardado en la carpeta config y se llama routes.rb. There's a rake task that will allow you to list the different routes that are available in the application. You simply run rake routes and it will tell you about it. There's a route format, a standard kind of format, in which first you see the HTTP verb, like it's the example here below. You see there's a get request, a route that will respond to the get HTTP verb. Then the URL must follow this format. You can have any kind of format, really. It's very flexible. In this case, it is expected that the path is recipes. And then we got this segment key is called. This is supposed to be a value, right? This is supposed to be some value. So then the controller that will process this request is the recipes controller. This is the syntax for it. It's the recipes controller. And this is the action. You see the controller, a hash symbol followed by the action. Here you see the URL format, in which this is a segment key, which is a variable parameter, can have different values. And this is the HTTP verb, okay? And, well, there are different types of routes. You got the root route for the application. The root route is the route that is meant to be serviced whenever the user goes to the root of your website. For instance, if a user goes to example.com, well, that's the root path, the root of the website. So if you'd like to run a special action, controller action, for the route, you can implement it in a way such as this. You got a welcome controller and you got the index action of the welcome controller. This will show the user a welcome page. Also, perhaps you got a pages controller and you got a home page as well. A home action in your pages controller. This isn't RESTful though. This isn't the standard naming convention in the RESTful sense. Anyways, if you do this, it will perfectly work for any user who wants to see your homepage, the root path of the application. Then the routing system has a couple of interesting conveniences. You see, if you define a route such as this, you got help, get help. The path is simply help. This will map to the help controller and the index action. As help, right? As help, the action is simply called, in this case, the route is called help. And why do you want this? Well, if you do this, Rails will generate two methods, the help URL and the help path methods that you will then be able to use in your application views. Your application views will have hyperlinks. You will need to create a hyperlink for the user to see the help. If you need to create a hyperlink, you got the help URL and also you got the help path. So the help URL will provide the entire URL to the help. The help path will provide a path relative to the, to the root. It's an absolute path to the help. The routes can be tested in the console directly by using a special object called the app. You can simply call the app and see what the help path is. Then we've got these other routes which are called the resource-based routes. I've told you that in many cases, your models will be considered resources, relevant resources that can be manipulated and sent back to the client, to the user, right? So when you got a resource and you want to support the standard REST, the uniform standard REST interface, you define resource-based routes. I'll show you some examples. For instance, you got photos. Photos is a plural resource because you got many photos on your domain model. Your domain model supports many photos. So you declare in the routes RB file, photos, you declare it as a plural resource, right? So when you do this, many different routes will be supported automatically. You see, this declaration here will allow the client to access all of these different paths with these different HTTP verbs, and each of these HTTP verb and path combinations will map to specific controller actions. So if the user says, okay, I want to get the photos, then the photos index, this is the controller, this is the action, this will get run. This will display a list of all photos. This then will provide a form by which the user can create a new photo. This will create a new photo in the database. This will display a specific photo. So all of these routes, these are 7 routes that get created by simply declaring a resource in the routes file. Automatically, it will happen automatically. You don't have to write each of these routes by hand yourself. You got this special method that will generate these 7 routes for you. Okay? It is like SQL, but a little more confusing. You mean the routes? Up to some point. Up to some point. The goals are quite different, you know. With SQL, you want to do some data access operations, data manipulation. In this case, you simply want to tell the application, your Rails application, what you want to see. I want to see, okay, this path, okay, this is the URL, this is the HTTP method. So the application must be smart enough to understand that and forward the request to the controller, the appropriate controller. And in this case, you see that happens automatically. You simply declare photos as a plural resource, and all of these routes get enabled automatically. Also, the helpers will get automatically generated. This kind of helpers link to URL, etc. Those get automatically generated. Sort of photo URL, you know, or link to. If you want to link to a specific photo, you can do so if you got photos declared as a resource. So exactly, this is what I just told you is what you see here below. You got the photos path, which will return photos. These are methods. You see this here at the left side. These are all methods that you can call and will return the paths that are necessary for the user to navigate in the view. When you got a view, later in the view layer, this will be very, very important because perhaps you'd like to build a photo gallery. So when you click on the small image, you want to show the big image, right? How do you do that? Well, here are some helper methods that will hopefully help you implementing those features. When you got a singular resource, you know, sometimes it makes sense to have a singular resource. When you got an e-commerce portal, you won't have many shopping carts for a user. You simply have one shopping cart. In that case, the shopping cart is kind of a singleton, and in that case, instead of declaring resources, you see here it was resources photos. Here you got just resource shopping cart, and this, instead of creating 7 routes, it will create 6 different routes. You see that there's a subtle difference here. You got if you want to show a specific photo, you have to pass the ID here. Here you pass the ID number. If you want to edit a particular photo, you also have to pass the ID number here. You got a segment key for the ID here. ID. When you got a singleton resource, you don't need the ID. The ID is assumed. The ID is known by the server, by the application. So you don't pass the ID in this case. When you got a singleton resource, there's just one instance, so that can be sort of obvious, right? To decipher what is the specific resource that you need to present to the user. Then it is possible to nest resources together. You got if you got an application such as Mercado Libre or eBay, then it will make sense that an auction will have many bits. Van a haber muchas ofertas por una determinada subasta en un sitio de remate, ¿ya? Entonces tiene sentido establecer una lógica de ruta tal que una subasta tiene muchas ofertas, ¿ya? Muchas ofertas de los potenciales compradores. Entonces, en este caso, tenemos la declaración de rutas anidadas, ¿ya? Y tú puedes tener una situación como esta acá, ¿ya? Acá tenemos una URL que está yendo al quinto remate, al remate 5, ID 5, ¿ya? Y estamos pidiendo que se cree una nueva oferta para ese remate, ¿ya? Entonces tú puedes establecer esas relaciones también a través de las rutas, ¿ya? Es muy conveniente en ese sentido. Esta cuestión lo que va a hacer es derivarte al controlador de bits, al controlador de ofertas, ¿ya? Pero al momento de llegar a new, en este controlador va a poder acceder como parámetro cuál es el auction. Y eso lo estamos viendo aquí abajo, ¿ya? Cuando veamos los parámetros, eso es la próxima clase, vamos a ver cómo un controlador recibe parámetros y cómo es capaz de recuperar, en este caso, el auction ID, ¿ya? Para obtener el auction y luego los bits. Entonces acá el auction se llama auction ID y claro, si es que estuviéramos buscando un bit en particular, ¿ya? Si estuviéramos buscando un bit en particular, en ese caso sería auctions/5 bits/10, por ejemplo. Tengo el bit 10. En ese caso puedo recuperar el auction por auction ID. Puedo recuperar el bit simplemente pasando ID, auction ID y ID. Bueno, esto lo vamos a ver en la próxima clase en realidad. Ya me estoy adelantando un poquito. Pero es para que ustedes le tomen un poquito el sentido a tener rutas anidadas de recursos. And this is the last topic we'll cover today. Web services. So you're very accustomed to having a web browser and using the web browser to access a web application. Lo más común es tener un navegador web con una página la página principal de un sitio abierta y de ahí tú mandas requests para acceder y navegar a todas las partes de un sitio web, por ejemplo, ¿ok? Pero también las máquinas, los servidores se conectan entre sí para proveerse servicios, ¿ya? Eso es lo maravilloso de las tecnologías de la web. No solo es una cuestión cliente-servidor, sino que, bueno, siempre es cliente-servidor, pero tú puedes tener servidores de aplicación conversando entre ellos. Es como una especie de relación peer-to-peer, si tú quieres. Como que un servidor le puede pedir algo a otro servidor. ¿Cómo logramos esto con tecnologías de la web? Bueno, el protocolo por excelencia, por antonomasia, la manera de hacerlo, usando el protocolo HTTP, ¿ya? Hacemos que un servidor le pida una cosa a otro servidor por HTTP y el primer servidor, el que invocó el servicio, vamos a decir, es como que un servidor es cliente de otro por medio de un servicio que es ofrecido por el segundo, digamos, ¿ya? Entonces, el primer servidor, el cliente del servicio, puede obtener esa información y luego enviarla a su cliente, ¿ya? Es como tenemos ya una arquitectura que se complejiza porque las interacciones no son solamente navegador web con un servidor web. Ahora, servidores web que hablan entre sí, servidores de aplicación que hablan entre sí, conectados por la vía de servicio, ¿no? Esa es un poquito la idea. So we got many services that are publicly accessible nowadays. You can go to almost any relevant application. You can go to Spotify, you can go to Twitter, you can go to Facebook, to Dropbox, Telegram, Amazon Web Services, etc. And all of these applications, all of these providers, all of these services will have a web service API. And web service APIs are nowadays commonly based on the RESTful architecture. So that means that you will be accessing the web services from your Rails applications by sending this kind of queries. You see, here you got RESTful routes. So web services are based on this kind of standardized routes. You see that the path is based on the resource name, and then you got all of these operations which combine the HTTP verb with the path specifics, right? So All of these services, Facebook, Google Authentication, Dropbox, Amazon Web Services, and so on, will support a RESTful application programming interface. We got here 2 sample scenarios, okay? I'll show you this with a mouse, it's easier. So we've got, imagine this is your possibly your Rails application. Your Rails application can provide a web browser, a user that navigates with a web browser, of course, the usual experience, But what if a user has another kind of application? What if a user is using a mobile application, application on the iPhone or in an Android phone? What will happen is that that application will talk to your Rails application by using RESTful routes. This collection of RESTful routes, we call it an application programming interface, because it will let an application developer create sort of a front-end application for your back-end web service. You can have even have another web application that talks to your Rails application to exchange that data using the HTTP verbs and using the RESTful routes we just saw. So web services are more common than you can imagine. I would say it is possible that the majority of web applications nowadays need to communicate with other web applications by using a RESTful interface, by using RESTful interactions, by connecting through HTTP and sending particular kinds of requests that follow the RESTful conventions. So you can create controllers in your Rails applications that can be called on, that can be consumed by other web applications. The way you usually do that is to use the Scaffold Controller generator and to modify the controller so that it inherits from this base class, which is Action Controller API, rather than Action Controller base. You use this class as the base class for a controller that will implement an application programming interface for a remote application to call you and ask you for resources and manipulate your resources. The new and edit controller actions aren't required because if you think, when a web server calls your application, calls your web service, it won't make sense for a web application to use a form. ¿Ya? Los métodos new y edit, las acciones new y edit, cuando se tiene un controlador para servicios web, no se usan, ¿ya? Porque new y edit se supone que mandan de vuelta al cliente una interfaz HTML. Pero ¿de qué le sirve una interfaz HTML a un software que está corriendo en un servidor? ¿Ya? Si tienes un cliente que es una aplicación web que te va a llamar a ti y te va a pedir cosas, te va a pedir que crees un recurso nuevo, no lo va a hacer a través de un formulario web. Va a mandarte los datos de otra manera, ¿ya? Entonces, por eso las acciones new y edit en general no se usan en estos controladores que son para APIs. Así que, ok, esto es todo el contenido de la clase, ¿ya? Todo el contenido de la clase. Bueno, obviamente el preámbulo que les dejé en video de los queries, ese lo tuve que poner como un preámbulo, como un video, ¿verdad? Porque no tuvimos clase la semana anterior y es súper importante esta materia de los joins. O sea, sin los joins y sin los queries, no le sacan ningún provecho a Active Record y al final no les queda claro cómo usarlo y es un problema, ¿ya? Entonces les tuve que pasar esto antes. Si lo hubiera incluido en esta clase se nos habría alargado mucho la clase y probablemente no habríamos alcanzado a terminar, ¿ya? Entonces para el próximo laboratorio, por favor estudien esta clase a conciencia, ¿ya? Porque les va a tocar hacer controladores, les va a tocar hacer una API y les va a tocar usar esa API para poder crear recursos, para poder obtener recursos. Ya va a ser un laboratorio guiado paso a paso, pero tienen que tener clara la materia porque si no, no van a saber lo que están haciendo, ¿ya? Lean sobre Action Controller, lean sobre el enrutamiento, están las dos guías oficiales de Rails. Lean sobre este formato de serialización de objetos que se ocupa en la web que se llama JSON. ¿Ya? Esto de JSON lo van a ocupar en el próximo laboratorio porque van a tener que crear objetos en JSON y mandarlos a la aplicación web de ustedes para que la aplicación de ustedes los guarde, ¿ya? Van a querer crear un usuario, entonces eso el objeto usuario lo van a crear en JSON y van a mandar el objeto a la aplicación y la aplicación lo va a guardar en la base de datos. Después van a querer pedir todos los usuarios que hay y la aplicación les va a mandar de vuelta un JSON, un corcho JSON, un array que va a contener todos los usuarios. ¿Ya? Entonces, familiarícense un poquito con esto que es JSON. Si van a ver a Wikipedia, van a ver que, bueno, está Douglas Crockford que inventó esta cosa. Y aquí ven el formato, ¿ya? Es un formato que es súper como fácil de seguir, es legible por seres humanos, ¿ya? En vez de una serialización en XML o en formato binario, acá es fácilmente legible esto, ¿ya? Tienes básicamente algo que se parece a un hash de JavaScript, ¿ya? Esto es muy parecido a un hash de JavaScript o un hash incluso de Python, ¿ya? Los hashes en Python se declaran con corchetes así que el hash de JavaScript es muy similar y es como un diccionario en Python. Entonces, después acá tienes un pares clave-valor. Clave, first name, valor John. Clave, last name. Entonces, ves que esto, así, te permite serializar un objeto. Tú puedes describir todos los campos, todos los atributos de un objeto, ¿ya? Es como, tienes toda la información de estado de un objeto, ¿ya? Que la puedes describir usando JSON. Incluso puedes poner colecciones, ¿ah? De objetos. Acá tenemos un array. Este array está vacío, ¿ya? Este array contiene dos números de teléfono, ¿sí? Los dos números de teléfono son objetos también, ¿ya? Es como que un objeto parte con corchete, termina con corchete, y acá tenemos pares clave valor. Acá hay una lista de objetos que son los números de teléfono, por ejemplo, ¿ya? Entonces es un formato súper flexible de ocupar y fácil fácil de escribir. Hay un validador universal que es el JSON-lint. El JSON-lint les permite agarrar un código, un objeto JSON como este, ¿ya? Y tú puedes ir a JSON-lint acá y pegar este objeto y lo puedes validar. Hay veces que cuesta escribir el JSON a mano, hay veces que uno se le olvida los corchetes o está escribiendo mal las comillas o cosas por el estilo. Esto por lo menos te dice si es que es válido el JSON que tú escribes, ¿ya? Y este JSON tú después lo puedes tomar y se lo puedes mandar a tu aplicación web. En vez de usar un formulario web para mandar un usuario, podéis mandarle un objeto JSON a tu aplicación, ¿ya? Y así es como los servicios se comunican. O sea, así es como un servidor se comunica con otro servidor, por decir, ¿ya? Así es como un servicio web puede implementarse. No es todo HTML en la web. Cuando se hace interacción por medio de servicios, no tiene sentido el HTML porque los servidores no leen párrafos, ¿ya? El software no le interesa leer párrafos, le interesan los objetos, ¿no? All right. So that's all. It's 10:20. If you still have a few minutes, I can show you a short demo on how to create a controller and how to use it. Otherwise, if you have to go to another class, please do so. This stream will be, of course, on YouTube, so you can come back later if you want. Super. So I'll go to my code folder. I'll go to, let's see, there you go. So we got a class, my folder for class 5. I'll use RPM to switch to my preferred version of Ruby, which is 261, and I'll use the Rails 6 gem set. So I'll quickly create an app. I'll see if in the meantime, because this can take a minute or two, if you got any questions. Okay, very good. Pleased to see a demo. With pleasure. I'll give you a demo. I'm sorry if in the first part of the class I went a little fast, but this is quite a dense class, it has many concepts, many topics, and I just wanted to make sure I covered them all, and I also take advantage of having this class uploaded as a video. So if any part sort of still baffles you, I'll try to provide an index for the different parts of the class on YouTube. I'll put a comment and put links to the different parts so that you can jump easily. I'll try to do that later on. All right, there's a gem that's a little slow to install. This is about style sheets. It's meant for views, the Sask gem. It has some extension written on C language, so it's running the C compiler, and that takes time. So what we will do is to create first a model. Can be simply a user model or customer model or whatever. Then I'll implement Scaffold Controller for the user. I'll show you some examples on how to sort of work with a controller, okay? There's a tool, by the way, that I'll publish on the course website, which is called Postman. I'll see if it's still available. I think, yeah. Postman is the tool we use to try services. I think I got it installed. Yeah, I got Postman. I'll try to use Postman. It's not so easy to get started with it, but I'll have it open just to show it to you. Okay, we'll wait until this thing installs. It takes a long time. So this is an application that will facilitate the task of creating requests, HTTP requests for you to try services. For instance, I can create a user GET request. Okay. So here I got a collection of requests. Let's wait for this to install. Okay, got the application created, REST demo. I'm sorry. Bundle install. Oh, it's running Sask again. Gosh, I don't know why Rails does this. You know, you create the project, it will run bundler on the project while it creates it, and then if you go to the folder and run bundle install again, it will install all the bundle, all the gems. So this is quite annoying. I'm sorry about it. If you got patience, stay with me. Otherwise, I'll continue, and you may see this later published. Okay. So we will follow this this way of creating the controller. So here you basically put the URL of the service you want to test. So we want to get a user, for instance, user 1. And well, first we need to have our application running, you know. But the thing is that this will talk to your application and retrieve the user with ID 1. This is a GET request, and this is the path. This is a standard path. If you go to and see the slide that I just showed you in the class, go back to these slides here. You see when you got the GET method and you got this path would match this, you know. You want to display a specific photo. In this case, we're going to get a specific user. So I'm just following the convention, you know. Then we may try using the post verb, right? And trying to post to photos, to users in this case. We'll try to post to photos an object. And I will try a very simple object. I'll create a user model, the most basic model possible. I will only put name on the user, and that's it. Yeah. So this tool, which is called Postman, I'll put the link on Canvas for you to download it. It's a you got the download link there, you know. Just download the app. Yeah, I'll put the link to the download page straight. Let's see if I got my, yeah. Great, so I'll jump to the course page. WebTech. And here below, routing and REST, I'll put a link to Postman. Yeah, it's like Open Broadcaster is eating my CPU. I just hope I can quickly create what's needed to show you this small example. There we go. Very good. At last, so we'll create a model. We'll just call it user, and the user will have a name and it will be type string. Okay. Very good. Very good. Now, name Claudio, right? Okay, we just created a user. Sorry, I'm going a little fast. We'll create a controller. I'll use Scaffold Controller. All right. Yeah, and I'll let it generate everything. So then I got my Scaffold Controller. I can open the folder. I can show you around. I can show you the controller that got created. Go to the app. Go to controllers and what the user's controller. You see, I just put the controller name, the resource name, the model name, and it automatically created the proper controller name for me, which is pluralized user's controller, right? And here we've got all the basic methods already implemented, and this will support HTML as well as JSON. So if I go now and start my application, I can simply start the server like this and attempt to get the first user. Could not get any response, and that's because I went too quick. The server wasn't running yet. Yeah, so what I'm getting is an exception now. Let's see the exception. It's yelling at me that there's some routing error. Yeah, there's a routing error, and it's very good that it's telling me there's a routing error, you know, because I skipped that part, and I showed you this in the class. It is very important for you to see the routes first. So we go to the routes file, and we will implement a route, a set of routes. So we say resources, users. User is a plural resource, right? So now if we go and we list the routes that are available, break routes, let's see what it says. It will give us a list of all routes that are supported in the application, which are quite a few. See, there are, these are the routes that are supported for users. You see, this is a set of rest of 7. I think these are, yeah, these are actually 8. What we see here, the 8 routes. Yeah, we see 8 routes here. Get, post, get, etc. So we got routes to create, to edit, etc., etc. Now we got the server running again. We'll wait it for just to run. So we got the server running. Then we'll attempt to send the request again. It's loading. Right, so it is giving us an HTML response, But we can also ask this to show us JSON. How do we do that? 1.json. You see different representations here. Now the thing that baffles me a little is that the name of the user should appear. You know, I call the user Claudio. Yeah, well, it's showing us the the HTML page. There's an HTML view that gets generated if you call it without the JSON. If you call it JSON, it will give you back JSON. Now, the fact that the name doesn't appear is a little confusing. Let's just see that. Why it doesn't show us the name of the user. So, okay, if we check the schema, there's the users table with a name attribute in it, so that shouldn't be the problem. Then we got the users controller. The users controller, we got the show action, which is the one we're calling. Here, you see the comments. It says, these are the supported routes. You got get users, indicating the user ID you want, and you also got this will return HTML. The first case will deliver HTML back. The second case, you put .json and this will deliver a JSON object back, a serialized object. So I'll do some debugging just to see what happens. Yeah, we got a set user. So this is yeah. You see that this method set user gets run before any request, before any of this actions is executed. So we got the user already available for us. There's a user attribute available. So I can just use the logger.debug and give this a descriptive message. Just say we are in the user's controller. And this is the show action. Rather than using colons, I'll use a hash, which is kind of the standard way to indicate the controller and method. Then I'll use I'll get the username. I'll try to print it to log to see if it's retrieving it well. Got the user. So again, I can start application. Oh, have to wait for the application to get started. Claudio. Yeah, so the user is being loaded correctly. You see, we got a name. So there's perhaps an issue with the way in which the response is being rendered back to the client. What we can do is to explicitly go to the show method. I just copy and paste this code, which generates the response for the client. So I'll use this as a kind of template. Yeah, there we go. So I wanna render. Yeah, I don't want to render show actually. Oh yeah. What I want to do is to render JSON. Yeah, I want to render JSON. It's kind of strange. I have to do this by hand. Should work automatically out of the box. I'll just try doing that. JSON user. All right, so in case it's HTML, I'll show the corresponding view or page with a OK status and show the user in this case. Otherwise, if it's JSON, well, the status should also be OK. We'll try this. Hopefully it will work. Otherwise, I will just end the demo for now and I'll try to tweak the pieces myself and see what's wrong, and then deliver the working example to you for you to see. There you see, Claudio. Yeah, then it works. You know, it seems that the basic version of show will not allow you to see the entire object. You know, you have to, unfortunately, you have to code this yourself. You have to basically tell the controller action how to render the response in the case if it's HTML or if it's a JSON kind of response. In case it's HTML, what you'd like to see is, of course, a web page. You'd like to see HTML like this, you know. But if you are asking for JSON, then you want to see the JSON. So in case you ask for JSON, you want the complete user object to be rendered. Otherwise, you won't be seeing the attributes. In this case, here we're seeing the ID, the name, all that, you know. All right, so what else? What else I can show you? Well, I can show you the plain route. The plain route, get all the users. I can try to see if it's possible that users.json works. Yeah, users.json will skip the name attribute for some reason. Yeah. I'll dig deeper into that and show you how to do it properly. For now, this is the basic thing I just wanted to show you. You know, how to create a controller, how to interact with the controller by using an application such as Postman that will allow you to construct a request and easily execute it in order to see what the result is. So there are relevant requests you can run if you wanna. For instance, create or update a given model. And I think we could attempt that. It's not really that easy to do. I mean, yeah, we could try updating a user. Let's see the route format for that. Okay, let's remember what the routes. So if you wanna update, then you have to passing the ID of the resource you want to update. So this is correct. We're using a patch. Then we have to pass the resource we want to update. Then we have to see if there's something specific. Yeah, we have to pass the object. Let's see if we can. Raw, yeah, it's raw, and the format is JSON. Yeah, you have to do that. You have in the body of the request, you put the object that you wanna. So I'll change Claudio for whatever other name possible. Yeah, my son is Manuel. I'll put Manuel here. Yeah, and I'll simply delete this stuff. You know. All right, so we'll try this. There's a comma that's not necessary there. So, okay, I'm patching the first user, passing this object as the request body. And the request body, I'm passing this as raw JSON, JSON content type. Then if I run this, let's cross our fingers. Exception code. Okay, it's telling me something went wrong with this. Okay, invalid authenticity token. Yes. What we have to do is to change the class from which this inherits. I think if we change the class and have it inherit from API, some restrictions that kick in will be disabled. This is a security control that a regular controller has. We have to disable it in order to use an API. Yeah, tell us no method error. Yeah, for some reason, even though the controller seems to have the proper action to handle this. Let's see. yeah, it can work with oh yeah, we have to put JSON here. Seems that's likely the problem. Yeah, kind of difficult to follow this. Let's see. Well, this will render the response in different formats. Doesn't make sense to put HTML, you know, if the to put JSON if the response is HTML already, so that won't work. Let's see if instead of passing the array, we just pass the plain object like that. That's the object, you know. Before this, we had an array. Yeah, it still fails. It's not really that friendly to use, you know. So yeah, I'll have to figure it out, you know. Have to figure it out. It's not really that. Yeah, here we got the page. You can switch from raw to preview. Preview in case you got HTML is easier to. Okay, respond to. Okay, yeah, I think that's because. Well, it's basically telling that the respond to method is not defined for the object. This is weird. This is very weird because this code was automatically generated, you know, by the scaffolding. It's not our code. It's code that got provided for us. So for some reason, it's not working properly, huh? Yeah, and at least here you see the parameters of the request. We're sending an object that this is the object. This is the object we sent. This is the user with which we want to commit the update. This is very useful to inspect. You see, we got JSON, and there we are passing in the user we want. Now, perhaps there seems to be a problem with the parameters. Yeah, there seems to be a problem with the parameters here. Yeah, it will fetch a user. It will fetch a user. So here's the user. This is the user. This parameter here is the user. So this is correct, you know, this is working correctly. If, yeah, if we do the same thing as before, this is the last thing I'll try. If we go to update, I'm sorry, I'll copy the log here. This is update. We got the user and we got the name. The name I'm trying to change it for Manuel. So let's start again. All right, so let's go back. There got ID 1, Manuel, and I'm trying to perform an update. Yeah, it's still the same problem. We'll see if it printed out anything interesting. Yeah, it still prints Claudio for some reason. Yeah, because what the set user method does is to fetch the object by its ID. The ID is Claudio anyway. The thing is that the object has to be updated. Yeah, here's the update. You see, here's the update. So perhaps the logger should put it there. Yeah, now I can see again if something relevant is printed. Let's see again. Yeah, update as JSON. Set user. Yeah, the set user seems to be giving us some error. Set user. Yeah, well, I have to dig deeper into this. I'll finish the example and post it for you to see in Canvas. I'll add some comments. Was unlucky that I couldn't show you the update, but I'll try to have it working for you. It will be very interesting if you can install the Postman application on your computer. What I can do is to then share this collection for you to download on Postman and try yourself. It's possible to generate a link and share whatever collection you got with requests. I can save this request, actually the first request I had, the one in which I simply asked for the, I will put none there, I asked for the first user, right? That's what I did in the first one. Yeah, well, there seems to be problems now occurring with respond to for some reason. It broke. At some point, there's something I did that broke the respond to. I'll investigate and try to come up with a definite answer about it. There's something I'm overlooking. I'm not putting attention to, and for some reason fails. So I apologize for that. So it's almost 10:50 now. I took another about half an hour to show you all this. It's not really that easy to get all running. Yeah, what do you say, Francisco? Could be that being asked from on-site protects the user info. Yeah, that's what happened with the error I handled by changing the base class. I changed action controller base for action controller API, and that fixed the request forgery problem, right? But now I'm having another problem, which is related to rendering. And when it renders the response, it fails. For some reason, it breaks. So again, I'll try to fix it for you. I'll publish the working example for you to study. And that will be all for today, right? Please do this for next lab. Next Thursday, you will be working with controllers, doing the same kind of thing I've just shown you with Postman. So, okay, I hope this introduction, this small crash course, well, with few issues we had, makes sense for you and helps you study. Thank you very much for attending this class. I hope to see you next week, and please let's continue interacting in the forums if you have any questions. Thank you.